So in the chapter sound, we had done a few things up to the last class. In the last class, we had done about the speed of sound. Okay, we had done frequency, amplitude, and we had also done one topic, that's echo. So these were the topics that we had completed in the last class. Okay, everyone is clear with these topics which we studied in the last class?
Yes, sir.
Okay. So any doubts up to here? See, the wave velocity, we had done one thing, the wave velocity of an object, the wave velocity or the speed of sound is given by the formula V, and this is equal to F lambda, where we had discussed the characteristics of frequency and wavelength. Okay. So what is wavelength? Yeah, how do we define the wavelength? Yeah, Prince, how do we define the wavelength?
Sir, it is the distance between two consecutive crest or two consecutive through.
Okay. Then can sound propagate through vacuum? Can sound travel through vacuum? Harini,
Yes, sir.
can sound travel through vacuum?
No, sir.
No,
Needs
sound
a
cannot.
medium.
Cannot travel through the medium. Through vacuum, it requires a medium to travel. Now, today we will be doing the topics reverberation. So today we will do here reverberation, then measurement of sound energy, measurement of sound energy. How do we measure the sound energy? That is, we also call it as its intensity. So sound energy is measured. We'll see how the sound energy is measured. Then we will see ultrasonics and infrasonic and supersonic. These three words. Ultrasound, or it's also called as ultrasonic. Then you have heard about infrasonic. Then you study about
Yes,
supersonic.
sir.
Yes.
I've heard about them. I learned it in school.
Okay. So can anyone tell me what are supersonics? Is there anyone who has heard about the word supersonic?
About what, sir?
Supersonic.
Sir, it's like when a sound exceeds,
Hmm?
when an object like exceeds the speed of sound, like goes
Yeah.
faster than the speed of sound.
Okay. So that's correct. If an object travels at a speed greater than the speed of sound. Okay. So such a speed is called as the ultrasonics, supersonics. So generally, the fighter aircraft, they have supersonic speeds. They travel at a speed of greater than the speed of sound. Certain missiles, they also travel at the speed greater than the sound. So
Sir,
there
I
you
have a question. Can a fighter jet go into space and come back on Earth?
Yeah, what? Just repeat your question.
Can a fighter jet go at the speed of sound, go into space and come back to Earth?
Okay. See, traveling at the speed of sound, that's a different thing. And going into a space, that is a different thing. Okay. See, the property on which the aeroplane works, that is because of the presence of air. Okay. So if there is no air, our aeroplane will not work. Okay, so if there is no air, then the aeroplane will not work. So you can't assume that the aeroplane will go into space, right? The rockets that they work on the principle of action and reaction. But aeroplane has a different principle. So aeroplanes can't fly into space.
Sir, I have a
Okay.
question. Can
Yes.
lightning be an example of supersonic?
Of course, lightning is an example of supersonic.
Okay, sir.
Okay. Because over there, in the case of lightning, if you see the speed of light, the speed of light is much greater than the speed of sound. There is almost no comparison. Okay. The speed of sound is just 0.3 kilometer per second, whereas the speed of light is 3 lakh kilometer per second. So there is no comparison between. So let us see, we will see what is reverberation, and we will also observe.
But
Yes.
a while ago, I searched up a flight. Its name is X/15 Flight 90. That flight went to space and came back.
Which one?
Flight X/15 Flight 90. I'll send the link in the chat.
Okay, see, there are many mysteries you can look into. Okay, there are many mysteries which you can look into. So, if you want to travel into space, so I just told you that that is a different phenomenon. You cannot just travel into space. Okay, because the ability of the aeroplane to fly off, it will decrease when there is no air.
Then how did that flight go into space and come back?
So we need to see what are the mysteries, how it worked. Okay, maybe the aeroplane has some velocity. Maybe suppose the aeroplane is traveling with a high velocity at a very high altitude. So over there, if suppose the inclination of the plane changes, then whatever velocity it has, it will continue to travel with the same velocity. And if it continues to travel with the same velocity, so it may enter into the space. Okay, but after that there will not be any guide. Okay, so I am just saving your link. I will look what you are saying. That still there. I told you that there are a number of mysteries. Okay, so I look into this mystery. What they call space. To see. Okay, anyone has any other doubt?
No.
No. Okay, let's see multiple reflections, reverberations, and then we'll complete this. Okay. So in the last class we had done this one. How does sound propagate? Then sound waves are longitudinal. This also we have done. Characteristics of a sound wave, that is frequency, amplitude, and speed, also has been done. Okay. So all these diagrams, they show you how about different waves. Like if you can observe the first wave, it has a very low frequency. The number of vibrations per second is very low for the first sound. That is the wave shape for a low pitched sound. Low pitched means the number of vibrations per second, they are very less. It has a less frequency. The second wave you see, it has a high vibration. It has the number of vibrations per second has increased. So this is a wave shape which represents your high frequency or a high pitch sound. Here you can see the two waves. They have a difference of not the frequency, they are having the same frequency. If you observe these two diagrams, they are having the same frequency. So they have the same frequency, but if you observe over here, the see, both of them, they have their maxima at the same point, but for this it has a greater amplitude, for this it has a smaller amplitude. So the second wave, it represents a sound wave having a louder noise. It is a louder wave. The first wave is the same sound wave but with a lower one. Okay. Then we had discussed about okay, let's see the question. We have these two questions. Calculate the wavelength of a sound wave whose frequency is 220 hertz and the speed is 440 meter per second. So we will solve these two questions. Chavan, which formula will be used in the first question? Yeah, Chavan, which formula will be used in the first question?
Wavelength by 3.
Which one?
Wavelength by 3. Sound is equals to wavelength by 3.
Okay, so compute everyone. Rishika, what will be the answer to compute it?
Yeah.
Compute here. Calculate the wavelength. So here the wave velocity V is given by f lambda. Do you remember the formula? Wave velocity is given by f lambda, and we want to compute here the lambda or the wavelength. Wave velocity here V is given as 440 meter per second. Frequency is given as 220 hertz, and we want to compute wavelength. So tell the answer. What will be the wavelength? Rishika, what will be the wavelength?
1 second, sir.
How much?
Sir, 2.
2 meter. We get the wavelength equal to V by F, which is 440 divided by 220. If there is any one person is not understand, person does not understand or not getting having any confusion, so please talk. Okay, your ultimate solution is just talk. If you talk, tell me, then only I can provide any solution. Okay, anything you have not understood. So by dividing it, you get 2, and since SI unit of lambda is meter, so therefore the wavelength in that medium will be 2. Okay, there is one common question, and this is a very high, you can say a hot question. Okay, let's try to answer it. So what do you think? Do you think that the frequency of sound will change when sound enter from one medium to another medium? Suppose sound enter from air to water, so will its frequency change or remain the same? See, the speed of the sound wave is different in different medium, right? In air, it is the minimum. Then after that, it is still more in liquids. Then it is still more in solids. Okay. So, what do you think? Will the frequency of a sound change when it moves from one medium to another medium?
Yes, sir, I think it will.
Will the frequency change?
Yeah, I think so, sir, yes.
See, the frequency will not change. Frequency depends on the source which is producing the sound wave. So the frequency depends on the source of the wave. Okay, wavelength will change, speed will change, but the frequency remains constant. It depends on the source. The number of vibrations created per second, that depends on the source. So this is a very high order question, which you should remember, that the frequency of a wave, any wave, whether it be light wave or sound wave, it depends on the source. It does not change while passing through any medium. Right?
Okay, sir.
Okay. Now the fourth one, a person is listening to a tone of 500 hertz, sitting at a distance of 450 meter from the source of the sound. What is the time interval between successive compressions from the source? Okay. So what first of all tell me what all things are given and what we need to compute. Yeah. What all things we need to compute here and what is given. Question is simple, answer is simple. You just read it 2 times, 3 times and give me what has been given. Okay, so I will ask the person, Oro Smith will tell me. Oro Smith,
Yeah,
Oro Smith, what is this 500 hertz?
the frequency of the sound.
Frequency of the sound. Okay, so can I write it as F equals to 500 hertz?
Yes, sir.
Okay, and what is this 450 meter?
Sir, distance.
Distance of what? Distance of what?
Sound from the source.
Okay, so here you have a source from which the sound is being produced, and from the source there is someone is sitting over here, and its distance is 450 meter, right?
Yes, sir.
Okay. Now, see this three. What is asked in the question? See these three. See these three. Can you answer? Okay, Harini, how are these things related with each other?
Mm,
Yeah, Harini, how are all these things related with each other?
the
Okay, what we have to compute? Harini, what do we have to compute here?
meaning,
How, what?
like, what do you mean, sir?
What is to be computed? What is to be calculated? I don't want the solution. I just want to know what is to be time or time period.
Time period.
Okay, we need to compute here. The time period is to be computed, right?
So we
So
have to find the day, like the time taken for one, like
no, No. See the question carefully. What is asked? You are asked what is the time interval between successive compressions from the source? Okay. So what do we call that time? The time between two successive sources. Two successive compressions. Just it is understand. Okay, Chavan Kaushik, what do we have to calculate?
With the interval between successive
Okay.
compression.
Is there any specific name given to that time?
I don't remember, sir.
Okay. Prince, is there any specific name given to the time between two successive compressions? No answer. Okay, let me ask everyone then. Siddhisri, Harini. Okay.
We were supposed to find the time period, right?
We are supposed to find the time period. Understand the question. It is asking you to find the time interval between two successive compressions. So, two successive compressions, like they are just similar to the time between two crests. Like I told you to understand this. A crest represents a compression and a trough represents a rarefaction. Okay, the time taken between two crests. So this is the same time which we call as the time period. Okay, so the question is very simple. It just needs your understanding what is asked in the question. So the question asks us to compute the time period. Indirectly, it is saying us to compute the time period. So Orosmith got it.
Yes, sir.
Okay. So can you compute now? Orosmith, which formula will be used?
V is equal to F lambda.
V is equal to F lambda. Think of it. Think it. I'm giving you just 2 minutes for everyone. I'll ask again everyone. This is the data that has been provided. We have been provided with frequency. We have been provided with distance. We want to compute the time. Chavan, any answers?
No, sir. I'm trying to remember.
Try to remember. See, I'm just again giving you all the formulas. I'm again giving you all the formulas. You will tell me which formula is to be utilized. See, you have done the formula wave velocity v is equal to f lambda. You have done the formula frequency is equal to 1 over time period. Okay, and there is one fundamental formula that speed equals to distance upon time. Okay, so out of this, which formula will be utilized? Even if you can't tell now,
Sir, can you go back to question once?
yeah. Here is the question. Question 4, and I'm removing also everything of the previous question. This is only for this question. For this question, only this much is done. What we have done. So you can focus here for this question. Only this.
Okay, sir, can you go back to the formulas now?
So which formula should I pick up? Rishika, which formula will be picked up?
Is it the frequency equals the 1 by time period? Is it that?
Frequency equal?
1 by time period? Can we use
Yeah,
that?
frequency equals 1 over time period. That will be utilized. So frequency is given to us. What is the frequency? 500. So we put here, use this formula. We get 500 equals to 1 over time period, and hence the time period will be equal to 1 over 500, and that's the answer. You can convert it to decimal, and you'll get here 0.002 seconds. That is the time. So was there any role of distance?
No.
No, it was just given to confuse you, so that you get confused with the distance. So I hope now you will remember these three formulas. Speed is equal to frequency into wavelength. Frequency is equal to 1 over time period, and speed equal to distance upon time. Okay. Anyone having any doubt still? Prince, do you have any doubts?
No, sir.
Okay. So I will think that you people do not have doubt if you are able to solve the question. Okay, see. Reflection of sound we have done. Let's see this question, and if you are able to solve this question, example 12.2, if you are able to solve it out, then I think you have understood. But without looking anywhere, without looking into your books, you have to solve this question. Okay.
Sir,
A person,
my device suddenly ran out of charging, so I have to rejoin. Which formula did we have to use?
first read the question, see what are the things that are given.
No, for the previous one.
12.2, draw the diagram. Draw the diagram.
The time interval one. Which one did we have to use?
The previous question you're talking here,
Yes, speed by d by t.
this was this. Frequency equals 1 over time period.
Okay, so
Okay. So here, a person clapped his hands near a cliff and heard the echo after 2 seconds. What is the distance of the cliff from the person if the speed of the sound V is taken as 346 meter per second? So draw the diagram and then compute. Siddhisri, are you there? Siddhisri, are you there? You are not
Yes,
responding
sir.
from.
Sir,
So you
I
are not
was having
responding.
network issues, sir.
Okay. So your mic is working. Still, you are not responding. I was asking some of the questions. Okay. So Siddhisri, respond to this. Can you draw the diagram for this question?
Sir,
Can you draw a diagram? So someone claps from here, and there is a cliff. Okay. So the sound travels from the source to the cliff and returns back. And sound returns back to the same person. Okay. So they have given something as speed of the sound as 346. So we write here speed of sound, speed as 346 meter per second. Suppose the distance of the cliff from the source was d. D was the distance.
sir,
So
I'm done.
okay, what is the answer?
I got 170 by 2, which is I did it. It's like 685 meters.
It's 85.
Yeah, because distance traveled into V into T.
Okay, see. The formula of speed is 346. So put here 346 will be equal to the distance traveled is 2d. So we write here 2d divided by time, that's 2. Is it correct?
Yes, sir.
Everyone know the formula of speed. Speed is given as distance by time. Okay. So the distance sound traveled is 2d and time it took was 2 seconds. So as you can see, both the 2 and 2 cancel. What will be the distance traveled by the sound wave? Siddharth, you joined late.
Sir, that is because I had some problem with Zoom, sir. So I had to download and I had to uninstall and install again.
Okay, so is there any doubt in any of the questions or
No,
anything
sir.
that are you
Oh, I
understanding?
multiplied by 5. I thought the echo was after 5 seconds, not 2 seconds.
Yeah, what happened, Chaman? What's the answer you get?
No, sir, I thought the echo was a different number. I put 346 into 5, then did it.
Okay. Okay, fine. So we got here distance as 346. Okay. The distance of the cliff from the boy is 346 meter. Let's see another one. Every time whenever you have the eco problem, so in the problems of eco, you will use the distance as 2d. Okay, use the distance as 2d, then you will get your correct answer. Okay, let's see another similar question. Similar one. I think this everyone shall answer. Everyone shall answer this. Just exactly the similar question. An echo is heard in 3 seconds. What is the distance of the reflecting surface from the source? Write the formula and I want the answer in chat section. From everyone, I should get the answer in chat. Okay. So I am getting 4 answers I have got. And I think all 4 answers are correct. There is one answer. Chavan Kaushik, your answer is incorrect. Check your answer again. Do with proper steps. Write the formula. Chavan, can you show your answer?
I just multiplied it, sir.
Which formula did you use?
I did speed is equals to distance by time.
Okay, and what was the distance you took? Remember, we have to take distance as 2d.
Oh,
Every time I told you, whenever you use the problem for eco, okay? So in the case of eco, you have to use the formula speed equals distance by time, but here distance becomes 2d. Okay, Harini also got the answer. Very good, Harini. Siddharth, Siddharth, can you show your answer? Can you show your solution? Siddharth? Yeah, Siddharth, can you show me the solution? Chavan Kaushik. Oh, Chavan Kaushik, even after giving the formula, you are doing wrong. How did you get distance equal to 114? Siddharth, how did you took distance equal to 114? Distance is what we have to calculate.
Sir, 2D by 3 is equal to 342.
So, no, okay, 2D by T is 3 is equal to 342, right? So, we write here 342 equal to 2D by 3. Okay, then
Oh,
Sir, I did a severe mistake. I instead of putting the 42 over there, I put it 2 into 344 by 3. I put it like that.
just use it. See, the previous question was the same question.
Yes, sir.
Okay, so see, in this question, Harini got right,
sir, I
Rishika
got
got right,
536.
Oro Smith got right, Prince got right. Okay, so just you have to here 342 multiply 3 divide by 2. That was your answer.
Sir, now I got 513, sir.
You got?
513.
Okay, so that's correct. 513. Okay, so everyone can solve the problem of eco.
Yes, sir.
Okay, so now I'm giving you one question from my side. Try to solve this. Okay, and I think this no one will make mistake over here. Okay. So see, the question is, it combines two chapters. Okay, the question combines two chapters and it's a hot question. So I'll provide you a little bit of, first I'll let you do. If you are not able to do, then I will provide you a little bit of hint. Okay? So a boy drops a stone from a cliff. Cliff 340 meter above the sea level. Look, whether you will be able to get it or not. Okay, you shall be able to get this. Fine. Find the time after which he will hear the sound of the stone hitting the water surface. Here I am giving you the value of G. You have to use the value of G as 10 meter per second square. Okay. So try to understand the question. First of all, see what the question says, and then I'll explain you, and then you can solve this. Otherwise, if there is anyone that person can solve, so it's welcome. Take also, I'm giving you the speed of sound.
Sir, I got the answer.
Just wait. Speed of sound as 340 meter per second. So who has got the answer? Harini, you got the answer?
So I sent it to you.
Okay. Okay, Harini has sent one of the answer. We will check it. See, the question involves two topics. It involves two topics. What all things are there? You have the sea level. Here you have the sea level, and you have a cliff. So let's have a cliff. So you have a cliff over here, and from here a stone is being dropped. The height
Sir,
of
wait
the cliff.
the answer.
Yeah. You have
Wait,
sent the answer.
I'm almost done, sir.
Okay, fine. So
Wait,
do
sir, should we first find like the time it takes to reach the ground and then find the time that it takes to travel up again and then
Yeah.
add them?
No, first you have to find the time it takes to go to the sea level, and then you have to find the time it will take for the sound to reach to the top.
Yes, sir. So the same.
Sir, it's is it the sum of sound one and sound two like that?
No, not sound one, sound two. Initially, the stone is coming, the stone is falling down. You have here stone falling down. So here you have the stone, it falls down. So first of all, you have to find the time that the stone takes to reach the ground. Okay. Then secondly, once it hits the ground, a sound will be produced. So how much time will this sound take to travel from here to the top? Okay. So
Sir,
let's
we can
discuss
write
this.
that technically as height is equals to 1.5 g, then T1 being the sound squared. We can do that, but then I'm getting weird equations.
Okay, let's say first of all we want to compute T1. Okay, so by computing T1 we can use the formula S equal to UT plus 1 by 2 GT squared. Okay.
Yes, sir.
Height is 340, so we write it 340 equals U is 0, so 0 into T plus 1 by 2 into G, which is 10 into T squared. Okay. So we get here 340 into 2 divided by 10 equals T squared. So 0 and 0 cancel. Okay. You get here 68
T is
is equal to T squared, and hence T will be equal to under root of 68.
Sir, I got the answer in under root like that, but I don't know if it was correct or not.
Okay, so if you get this under root 68, then it is up to here it is correct. And after that, you have to find the time it takes for the sound to reach from the ground up to the top.
So we can just do H by V for that one.
Okay.
T2
So
is
that will
equals to H by V, and then we can just add it up, I guess.
so when the sound is traveling up, there is no use of acceleration due to gravity. On sound, there is no acceleration due to gravity. Its speed will remain the same. The speed of the sound is not affected by gravity. Okay, so your second time, if you compute, the second time T2 will be equal to distance by speed. Distance is 340, speed is
Oh, so it'll
340.
be 1.
So you get 1
So it will
second.
be 1 plus root 80, 68.
Yeah, 1 plus root 68. Compute the value of root 68 and get the answer.
Sir, root 68 is not a rational root.
Okay, so you still find it in decimal, correct up to 2 decimal places. Find out square root of 68.
8.24, so 9.24.
Yeah, it will be 8.24. This is 8.24 second. And if you add this to this 1 second, you get total time as 9.24 second. Anyone who is not getting, Siddharth, are you getting the answer? Are you able to understand?
Yes, sir.
Harini,
Yes, sir.
did you get the answer?
No, sir. I did a mistake after redo it again.
Okay, so now it's okay.
No, sir, I'm still solving it.
Okay, still solving. Prince, what about you?
I understand.
Okay, Aerosmith.
Yes, sir. Yes, sir.
Okay, so next we will see from the book. Okay, the next topic is multiple reflections. See, what do we mean by the multiple reflections? Here, what all the multiple reflections can do? It can also amplify a sound. It can also be used at different places. Multiple, then after that we will this, so it will finish. Okay. So multiple reflections, when a sound, when the same sound, it reflects back from the same surface a number of times. Yeah, Chavan, what happened? What happened, Chavan?
Nothing, sir.
The person whom you were talking with is visible under the camera.
No, sir.
Okay, see. So, reverberation. If you have the multiple reflections coming from the same, if a sound is being produced and that is being reflected from a surface a number of times, so such reflections, they are called as multiple reflections. Okay. And multiple reflections can result in they can result in a number of things. They can either be used in megaphones to amplify a sound. Okay. So see a megaphone and a horn. A megaphone is designed something like this, where if you speak a little bit, your sound is amplified. Okay. So it is amplified on the basis of multiple reflections occurring in the sound. Okay. So whatever sound you produce, it gets reflected in multiple times and then it is directed in one direction. So therefore, you can hear the sound louder. Whereas if you just speak up with your mouth, so your sound goes a number of, it has to travel a number of distances. So the sound energy dissipates, right? So megaphone, it helps in directing your energy in a specific direction and hence minimizing the loss of energy, therefore increasing your just 1 minute, increasing your ability to hear. Okay, so any doubt anyone has? So today we have completed all these topics. Still some of the topics are remaining from this, which will be completed in the next class. And we will have a test of this chapter on Saturday. So we'll have a test. You can expect test from sound chapter. Anyone having any doubts, please go through this chapter. Okay. So bye everyone. Good night and see you all in the next class.
Thank you so much.
Bye, sir.
Thank you.
Goodbye.
Thank you, sir.